Hello, my name is Laura Hewerk. I live in Buenos Aires, but I'm doing an international exchange in Louvain-la-Neuve. I'm 23 years old, and I'm in my fourth year of my degree in business management. Now, I would like to answer one of the questions you gave us. I choose number 1, which is: what are the assumptions required to obtain that the OLS estimator is the best linear unbiased estimator among the class of linear estimators in the context of a linear regression model? For each assumption, give an example in finance of a situation where it could be violated in practice, mentioning each time what consequences it may have on properties of the estimator. The linear regression model, either singular or multiply, is this one, where EI is the error term for each observation containing all those factors affecting yi and other than xi. The OLS method is to find the estimates of beta I so that minimize the sum of the squares residuals. If we take the simple linear model, we can write the predicted or set values this way. And the error setting called residue is this one. The estimators arise from equation 1 and 2, and after work with them, you can prove this. OLS estimators are provided under these conditions: unbiased, consistent, and they have minimal variance. Estimators are maximum likelihood under the assumption that errors are normally distributed. The assumptions are: hope error is 0. The covariance between EI and EG is 0. That means independent errors. And in third place, the error variance is equal than sigma squared. When the event homoscedasticity no longer met, the estimators remain unbiased and consistent, but they will not be of minimum variance, which causes hypothesis test beta I is no longer valid. To test heteroscedasticity, there are many tests. The most commonly used are Golfer-Quant test, Reusch-Pagan test, and White test, where the best of all is the White test. When the homoscedasticity event was not found, you can find an alternative to the OLS method, known as generalized least squares, which produce blue estimators. But there is a problem in the correlation of errors, which violates the assumption that covariance between EI and EJ is 0. When correlation errors occurs, the estimates obtained by OLS remain unbiased and consistent, but not within the minimum variance unbiased estimators family. Either with heteroscedasticity or errors autocorrelation, the variances of estimators are larger. If you take the variation model as explanatory variables, the largest dependent variable, the OLS estimators will not be consistent if there is autocorrelation of errors. In addition, the individual significant test and GTA significant test don't work anymore. The estimators are no longer blue. To test errors autocorrelation, you can use the following tests: Darwin-Watson test and Lagrange multiplier test. An example that violates the assumptions of Dr. Gauss may be the mistake of estimating the value of Argentinian currency. Using data from years 1900 to 1950, taking periods of 10 years, this does not follow a normal distribution, so hope error will not be 0. It could also show that the variance of the errors is not equal to sigma squared. And finally, if I take Argentina's currency between 1960 and 1970 against Argentina's currency between 1970 and 1980, the covariance between these two random variables will not be 0. This means they do not vary in the same way. Thus, we can see how all the assumptions are violated in this financial example. I hope you understand my work, and thank you very much. My name is Laura Hewerk.